Okay, I'm just going to record a select few of these problems that were on your assignment. So I'm going to try to do one of each type. Okay, so I'm going to do number 12. And I might go fast, so pause it if you need. An open box is made by cutting identical squares from the corners of a 16 by 24 inch piece of cardboard and then turning up the sides. Okay, so I have, it's not square like some of the others, that's okay. 16 by 24 to start with. Okay, and then we're going to cut, it says, cut identical squares from the corners. And how big are those squares supposed to be? This says the side of the square cut from the corner. So I'm going to cut these little corners off, and they're going to be X by X. Those are still squares because it says so. Okay, so that when I fold that up, when I fold along here and here and here and here, and I fold those up, I now have a box. It's no longer 24 long, it's 24 minus, so now it's only from here to here, right? That's what's going to go here. So it was 24, and I'm taking off an x on each end, so that's going to be 24 minus 2x, okay? And then this side is this one, and it started out being 16, so it's going to be 16 minus 2x. And then how tall is it? Well, if I fold along here, this end's going to be folded up, and so is this one, and it's going to be x tall. Okay, so it wants the volume of the box. Volume of a rectangular prism is length times width times height. And that's the beautiful thing about making this drawing. I can see the length and the width and the height. So the volume in terms of x is going to be the length, 24 minus 2x, times the width, 16 minus 2x, times the height, which is x. Okay, and you don't need to FOIL that out. On the ones with the boxes, these were the same, or the squares, I'm sorry, these were the same, so you would have had a quantity squared, but for this one, that's it. All right, I'm going to skip down and do number 14, so you can see one that is like this type, where they give you an equation, okay? And I'm going to make a picture to go with this so that it makes sense to you, okay? So what I have is a parabola, crosses, oops, down here, I'm sorry, at -8. And then it opens up, and I know that because it's a positive x squared. So this parabola is y equals x squared minus 8. And then there's a point somewhere on here. I don't really care where it is. It's just every single point on this graph that satisfies it is going to fit into this expression, this equation, okay? And this particular one wants the distance from that point P to, this one says the origin. The origin is at 0, 0, okay? So it wants the distance, which we know is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, okay? So I need to pick which one's going to be x1, which one's going to be y1. I should say x1 and x2. So I'm just going to go ahead and let this one be x2 and y2, and this x1, y1. So I'm going to go x minus 0, and then y2, which I'm calling y, minus y1, which I'm calling 0. My 0 doesn't look like a 0. Okay, so it looks like I get the square root of x squared plus y squared. Okay. Now it says write it as a function of the point's x coordinate, meaning that I only want these to be x's. So I need something that I can put in place of this y that has x's in it. Well, remember, they gave us this expression that tells me the relationship between every x and y coordinate on this parabola. So if I don't want y's, then in place of y, I can just put in x squared minus 8, because that's how you get y on that parabola. Okay, so I'm putting that in for the y, so I still have to square it. Okay, so I've got x squared, and then if I FOIL this out, first times first is going to be x to the 4th, last times last is going to be positive 64, then my outer is negative 8x squared, and my inner is also negative 8x squared, so minus 16x squared. And then these are like terms, so I can put those together. So I end up getting the distance is x to the fourth, and then that would be minus 15x squared plus 64, which you can't see. There it is. Okay. I also want to do number 16. It's kind of like this, but it's a little different actually. It's similar to number 14, but this one isn't asking us to express the distance. I have a semicircle, and again, they're having the P be all the X and Y's, just any X or Y on that semicircle. And then the equation that represents the relationship between X and Y is here. 9 minus X squared, the square root of that would give us Y. Okay. Now, this isn't asking us to represent the distance. This says express the area of the rectangle. And we did one like this in class, the area of the rectangle. We know that area is length times width, right? So I need to figure out how long this is, okay? And I always have kids that want to guess. Well, we're not going to guess. It's somewhere between 2 and 3 on here, but this is arbitrary. This is representing for any, the idea is that for any X or Y, what would because the rectangle could have just as easily be drawn like this, right? So I just want to represent for any, my eraser kind of stinks, any rectangle that could be in there. That's the whole point of the formula. So length times width. I need to represent this length. I don't know how wide it is, but here's what I do know. I do know that to get to point P, I have to go X to the right, and I have to go Y up. That right X up Y gives me this coordinate, okay? And likewise, this point, because this is a rectangle and a semicircle, and they're symmetric, then this is going to be also, this is going to be the negative X distance and the positive Y to get to this point, okay? So when I'm trying to figure out the length of this whole rectangle, it doesn't matter if this is negative. I still travel a distance of X. So what's the entire length of this rectangle going to be? It's going to be 2X, right? And then the entire width of this rectangle is just going to be whatever the Y coordinate is. So I can find the area in terms of X by taking the length of 2X times the height of Y. Okay. But again, it wants it as a function of X. So I need something to put in place of this Y that shows the relationship between X and Y. And what is it going to be? It's going to be this semicircle, because these points are strategically being placed on the semicircle so that those distances of X and Y can also be represented by this relationship. You're going to love this when you get to calculus, guys. It'll be super fun. So in place of Y, I'm putting the square root of 9 minus X squared, okay? And remember, I can't simplify this anymore because I can't take the square root of this because this is held by subtraction, right? And I can't, I gotta see what's happening here. It's trying to kick me out of the meet. And I'm gonna say, stay in the call. And I can't distribute into it because it's a square root. So that's my answer. That's what I get for part A. For part B, it wants the perimeter of the rectangle. Well, okay, we can do that. Remember, perimeter is equal to 2 lengths plus 2 widths, okay? And this is going to end up being in terms of X, right? Well, the length of this thing was 2X, right? So I've got 2 times this length of 2X, okay? And then the width, you told me was Y. I'm pretending you're answering my questions. Okay. But again, they only want it in terms of X, so I can use this relationship again to go for Y, because this is showing the relationship of every point on this semicircle. So I end up with the perimeter in terms of X is 4X, right? Plus 2 times the square root of 9 minus X squared. Okay, so that was 16. There's the explanation. And I'm also going to do 18. This one. Okay, so it says the figure shows an open box, so no lid on this, with a square base, okay, and a partition down the middle. All right, so here's my square base, X by X. Okay, the box is to have a volume of 400 cubic inches. Express the amount of material needed to construct the box area as a function of a length of its square base x. Okay, that's no problem. So area, okay, so if I wanted to construct this box right here, I would need the bottom of it, which would be, if I'm doing area, the bottom of this is going to be x by x, right? X squared, okay? And then I would need like one of these front pieces, right? And its area is x by y, length times width. And there's another piece just like it right here, right? So I've got two pieces that are like the front and the back that are x by y, okay? Then I'm going to have three pieces that are identical here, right? And they're x by y. So is this one. And so is this one. So three of them that are x by y. Okay. And since this was a square base, which is why these are the same thing. So I get the area in terms of x is x squared plus how many xy's? 5. Okay. I'm really close. That is not my answer. Why is that not my answer? As a function of the length of its side x. This has this stinking y in it. If I had some sort of an equation to represent the relationship between x and y, I could plug it in. But they didn't give me one like they did on that semicircle one. But never fear, we have the volume of this box, okay? And if I use these x's and y's, I know that volume is equal to length times width times height, right? So if the volume is 400, then that means the relationship between the x's and y's would give me x squared times y equals 400. Now, could I make an expression out of this that I could put in for this y? And the answer is, well, yeah, I could divide both sides by x squared. So I get that y is equal to 400 over x squared. So that shows the relationship between the x's and y's of this figure based on its volume. So I can put this in place of y right here. And I just keep everything else the same because I'm just substituting. But I can reduce here, right? Because this is technically over 1. So I could reduce one of these x's with this one. So really what I get here is x squared plus 5 times 400 would be 2,000 over x. Ta-da. I don't know if you can see that. I went too far down. There's my equation. Alrighty.